common factors and multiply. The second one is also easy because I realized that 12 is a multiple of 3, or 12 is divisible by 3. All I had to do is copy 12 and adjust one fraction. The next one is the last one and the most difficult because they have common factors, and multiplying will not give us anything, meaning it will not give us the least common denominator that we want. So I take 15 aside, and I know that the prime factorization is 3 times 5. I take 12 aside, and let's find the prime factorization. So Megan, will you tell us the prime factorization of 12? Megan, are you with us? Hello? Megan? Can you give us the prime factorization? Can you please give us the prime factorization of 12?
Can you say that one more time?
Yes, the prime factorization of 12.
I don't know it off the top of my head, but if you give me a second, I can give you an answer.
Okay, anyone else can give us the prime factorization of 12?
Is it 3 times 322?
Yes, but it has to be in terms of powers. That's correct. It's 322, but you have to write it. Yes?
3.
It has to be in the correct order.
3 and then 2 squared.
You mean 2 squared and then 3. Very good.
3.
Perfect. Okay, perfect. So now, the least common denominator has to have all different factors. That's the first thing I need to do. List all different factors. Different factors, I see 2, I see 3, and I see 5. Now, after I list the factors, all different factors I see, the next step is to identify the power of each. Notice that 5 appears with power 1. There is no discussion there. It has to stay with power 1. Notice that 3 in the first denominator has power 1. In the second denominator has power 1. No one adds powers. This is it. 3 is good enough. But 2 has power 2. And I have to copy it with that power. So now the least common denominator is, here's what I'm going to do. For simplicity, this is 4. 4 times 5 is 20. 20 times 3 is 60. Because that's the easiest thing to do. Otherwise, I'll have to multiply 4 by 3 and by 5. But I'm allowed to do whatever I wanted with factors. 4 times 5 is 20, and 20 times 3 is easy to multiply, which is 60. In any order, it doesn't matter. It's still 60. Next, 15, I took the liberty to multiply by something. I have to do the same thing to the top. 12, I multiplied it by something to get 60. I have to do the same thing to the top. Otherwise, I change everything and I will never get the correct answer. Now, from here, it's very easy to figure out what I need. The 15 is this. So what did I multiply 15 by to get 60?
4.
That's it. Which means I have to do the same thing to the top. Again, from here, this is easy. This is the 12. So what did I multiply 12 by to get 60? That's it. So 4 times 4 is 16, plus 5 times 31 is 155. Will you ever be tempted to simplify 155 with 60 and 16 with 60 by 2 and 155 with 60 by 5? Please say no. No, thank you. Thank you very much. You can because these are terms. So then when I add, I get what? 171 divided by 60. Now, I cannot leave it as is before I'm sure that it's in lowest terms. And maybe I have to take out the integers and change it into a mixed number. Notice that this is not an even number, so I have to continue with divisibility by 3. And if you add the numbers, you get 9. 7, 8, and 9. 9 is divisible by 3. So both numbers are divisible by 3. 60, 6 and 0, and 171. So I will divide by 3. I divide this by 3, and I get what? 57. And I divide this by 3, and I get 20. So the simplified form is 57 over 20. Now, you can say, can I try something else? Not really, because this is divisible by 2 and 5. And this is no longer divisible by 2 and 5. Now, if I want to take the integers out, I will. I have 2 integers because 2 times 20 is 40. And what is the remainder? 2 times 20 is 40. 57 minus 40 is 17. And this is it. Okay, this was a long procedure. Normally doesn't take that long, but I needed to explain where every step is coming from. 90% of the students have difficulties with this. And those who are not paying attention right now, we'll see. I hope that they master this and they know it all. That's my hope. Any questions?
We still have a little bit of difficulty with it.
I'm telling you, adding fractions, subtracting fractions, if I find students who can do this, I'm super happy. Yes, this is the most difficult situation. Okay, let's go on to, go back to our step-by-step procedure here. So we found out what is going on. We continue. We know how to do this now. We know how to do this now. Okay, use the prime factorization to simplify. We know how to do that. The following, okay, the simplification again. Write the fraction in its lowest terms. We know how to do that. Lowest terms. Write the fraction in lowest terms. 4 and 9. How will you write the fraction in lowest terms of 4 and 9? How many common factors do these two have? The answer is none, or just one. There is nothing you can simplify here. 4 over 9 is 4 over 9. Good. Lowest terms again, that's okay, we know this. Okay, what about 0 over 54? Yes, what about 54 over 0?
Undefined.
Thank you. Thank you very much. Excellent. Good. List the numbers in the set that are natural numbers. So 27 over 21. You can simplify it by 3, but it's not a natural number because it's negative. Natural numbers start with 1, not even with 0. So 0 over 67, I know you're going to say 0, but it's not part of a natural number. It's part of whole numbers and above. But 8 over 4 is 2. And 8 over 4, which is 2, is a natural number. 17 over 17 is 1, and that is a natural number. This doesn't even exist. The absolute value of negative 4. Can anyone tell us what is the absolute value of negative 4? What does it equal to?
4.
Yes, and that is a natural number. The negative 6 over 3, although it's negative 2, is not a natural number because it's a negative number. So yes, Okay, the same thing. They're the integers. The integers are the same, but they include 0 and they include negative numbers. But they cannot be 8/6. That's not going to happen. Okay, so you will not have any difficulties with this. Graph the fraction on the number line. This is difficult. 5/11. So if I'm asked 5/11 to present 5/11 on the real line, first what I'm going to do, I'm just going to divide 5 by 11. I get 0.45 actually. So this is approximately 0.45. First of all, is a positive number. I know it's a number between 0 and 1. In the middle, I will have 0.5. So therefore, 5/11 will be a little bit to the left of 0.5. So I will plot it right here. That will be 5/11. Now, another possibility is this. To show the unit between 0 and 1 somehow divided into 11 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know how I did that.
That was pretty good.
Of course, they are not equal. But 1, 2, 3, 4, 5, and this is my 5/11. I divvy up like from 0 inches to 1 inch. We have 16 ticks. 16. The same thing here. Now we have 11. Now, normally when we represent intervals, yada, 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 we're not going to do this. We're going to approximate and say it's a little bit to the left of 0.5. But this is the accurate way. Okay? Divvy it up as we did with all those pie charts and so on and so forth, right? They shaded in out of 7, there were 2/7. So that's the idea here. Okay, back to, good. Yes. Okay, the same thing. This is a little bit easier because we are only divided by 4, 1/4, 1/4, 1/4. But it's a negative number. So you have to be careful with this. So again, you have from 0 to -1. And you divvy it up into 4 pieces. -1/4, -2/4, -3/4. So this one would be -3/4. And of course, this is the positive side and this is the negative side. So that was easy because we needed to divide the unit in 4 parts, not 11. Okay, I think this is very clear now. I hope there is no problem. Okay. We know how to evaluate this. We've done a lot with the absolute value. And this again, same thing. Okay. Yes, we know. Fill in each box to complete the problem. 1/7 times what is 2/21?
2/3.
Say it again.
2/3.
2/3. Very good. Okay, multiply. We know how to multiply. Nope. Okay. Here, what I would do, I would put the 35 or -35/1 first. So let's do this one. So -35 and -5/7. So first of all, I will take care of the sign, always. I multiply two negative numbers, forget it. So this is now 35 over 1 times 5 over 7. I will not proceed before I simplify. There is no point in making it difficult, right? And I see that 7 and 35, right? So 7 divided by 7 is 1. 35 by 7 is 5. And now it's very easy. 5 times 5 over 1 times 1. So the answer is 25. So please remember, always simplify if you can. You make your life easier if you simplify first. Okay. So we do not need, that's a very good point. We do not need the least common denominator when we multiply or divide. No need of the least ever common denominator ever, except for addition and subtraction. Ever. Do not ever think in terms of the least common denominator unless you add or subtract. Ever. Good? Good. I think we had enough of this. Yes, so also 7 over 8 everything squared, we discussed exponential rules, but not this one. So if I have a over b, everything to the nth power, we discussed ab to the nth power. It's the same. So it's a to the n times b to the n. Same thing, same rule. A to the nth power over b to the nth power. So in this example that we have here, it's 7 over 8 squared. 7 over 8 squared, you either say 7 over 8 times 7 over 8, but we have this rule, which is much easier. 7 squared is 49. 8 squared is 64. And I applied this rule, which is the same with the rule that we discussed last time. Good. Now, if you square a negative number, remember the answer would be?
Positive.
Yes, a negative number raised to an even power. Good, same thing. Just be very careful. Maybe we should work on one of these problems. They look awful.
Torture.
Yes, yes, exactly. Okay, do we want to work on one of those?
Yeah.
Very good. So I'm just checking divisions. We discussed this, division, multiplication, just making sure there is nothing fantastic here. Remember, the trick is you must simplify before you do anything else. So this is not a difficult situation, but remember, look at how many, like 61 questions here. Nothing difficult. We touched up on everything. I just want to go back and look at those ugly ones. So you'll not have any difficulties here. Because we went over evaluate this. Yes, that's another thing that we should be doing. Okay, there is nothing here, but I just want to look at those two. I don't remember now which.
It was 30 something.
Good. So here's one. Let's take a look.